everyone, we're back and we're going to be discussing cognitive development in late adulthood. The aging brain is kind of a conundrum because on the one hand, the average brain shrinks about 15% between reaching full maturity at about between 18 and 25 years of age, and then what the brain will look like in old age. So it seems like that would de facto mean that the brain would be less effective, or that would explain memory problems or other kinds of things. But we have to remember the principle that we talked about in the last chapter, which is selective compensation. We have the ability to compensate for brain losses, as well as the fact that a lot of the loss in size is attributable to a decline in the number of neurons that are being deleted because they haven't been contributing to any cognitive task. So our brain doesn't generally shrink because we're losing neurons that we've been using. It shrinks because we're losing neurons that we haven't been using. Neurons are really expensive to maintain. They take a lot of nutrition and maintenance. And so if we can eliminate the ones that are basically just booster cells between two different cells that actually are containing information, we can speed transmission and actually make a more efficient brain. So the shrinkage is not always going to indicate a reduction in skill sets. Okay, so even so, there are some things that are going to be negatively associated with the loss of brain cells, and particularly in the hippocampus. This picture did not include any details about the hippocampus, but the hippocampus is that structure that they've highlighted mostly in black here and then with dotted lines because it's between some stuff. The hippocampus is the part of the brain that's in charge of temporarily storing whatever's going on right now. So you might call it the seat of working memory. It's also where information gets stored after you stop thinking about it, but before it gets transferred up to long-term memory. On average, the hippocampus of an 80-year-old is smaller than the hippocampus of a 20-year-old. And so some people think that some theories are pointing to the idea that the shrinking of the hippocampus might help to explain why, as we age, we have difficulty remembering recent details. What we had for dinner last night, or where we parked our car at the grocery store that we go to once a week for the past 25 years. We may forget today, where did I leave my car versus where did I leave it last week? Those kinds of deficits might be attributable to the shrinking hippocampus. So there are things that we can do to help maintain the hippocampus in a healthier state. One is schooling, which I see you guys are all doing. So good, yay. Education is one of those things that helps to keep our brains flexible, convinces our brain that we have new things that we need to be learning. So challenging ourselves, storing new information is a really good way to convince the brain that we need to be storing things. So schooling is a really important factor. In fact, they found that PhDs who are still teaching at the age of 70 tend to have much larger hippocampuses than their counterparts who have lower levels of education and are not engaged in their career anymore. So schooling combined with health over the lifetime, staying healthy is an important factor in maintenance of the brain. Like I said earlier, the brain is really labor intensive for maintenance. It takes a lot of energy. It takes a lot of nutrition. And so having a good diet, having an exercise routine that causes oxygen to be transferred in the lungs means that we're going to have more oxygen in the blood that's going to go up to the brain. And the brain is completely dependent on the bloodstream for its nutrition. And so when we get good oxygenated blood that's carrying glucose because we've been exercising, it helps to keep the brain in better health. And then finally, challenging ourselves every day. Like I said, the people who were still teaching college at 70 had brains that were bigger than, or at least the hippocampus was bigger than their peers who weren't still engaged in their everyday routines. Daily mental challenge is really important. I think one of the reasons why they found that the PhDs teaching college had less brain shrinkage is that to teach at any level, you have to be really flexible and responsive to your students, and they may ask questions that you haven't got a rote answer for. You may have to reason it out or remember something that you read a while ago that would help to answer their question. And so having that kind of daily mental challenge is really important. Now, not all of us are PhDs teaching college, so what can the average person do? Well, these guys are playing bridge. There's been research that has shown that playing bridge is really helpful to keeping the brain healthy, keeping the mind sharp. The bridge clubs that they've studied, the members tend to have less reduction in brain volume than people who don't engage in that kind of challenging play. The thing about bridge that's really interesting is that it's a social game because you're playing with your partner and also trying to play against your opponents. It requires a lot of memory. It's got really complex rules. I don't know how to play it, so I'm just telling you what I've heard about it because I don't know how to play it. One of these days I'll take it up to try and keep my hippocampus nice and fluffy because anything that's new. Now, if you become a bridge master, it's not going to have the same kind of effect as going from not knowing how to play it to becoming competent. It's the change that seems to be the important factor. So trying new things throughout your life seems to be the theme that's really important for reducing the rate of shrinkage. Other factors that are important that are changing in older age. In order for us to think really well and complexly, we have to be able to inhibit incorrect responses. That's a really important skill that you probably don't think about. Oftentimes older people will tell younger people, how can you be studying with all this noise around you, or while you're watching TV or a YouTube video or things like that? And they'll say, you need to concentrate. And the younger person is thinking, I can divide my attention. You're not really technically dividing your attention. What you're doing is you're able to selectively inhibit your attention on one of the things at a time better than an older person can. As we age, we become less able to inhibit our responses. We can't tune things out as well as we once did when we were younger. So what we're talking about is that our control processes become less effective. So what that means is that we can't selectively attend as well as we once did. We can't choose what to put our attention on as well as we once did when we were younger. So noise in the background will be very distracting when we're older compared to not even noticeable when we're younger. Figuring out the rules to things will be harder as we age, when we're confronted with something new. If you've ever tried to, as a younger person, get a person from a generation or older than you to, let's say, play a video game with you, the older person may have difficulty figuring out the rules, even as you're explaining them and over-explaining them. You're like, how are you not picking this up? Well, it's not because they never could pick up rules. It's because with age, new rules become more complex than they would have been to them when they were younger. It's part of those control processes, being able to focus on one thing and ignore something else. And then having strategies for problem solving. As we age, we oftentimes will try first strategies that have worked in the past. And so that means that we may waste some time trying things that should have worked, because I've encountered a problem kind of like this before. And then we realize, wait, the solution's not working. Now I have to back up, reframe the problem, figure out what I want to do now. And so it slows us down. We have difficulty as we age, not just jumping in and trying to solve it based on what we think we already know. So those are the factors that are all tied to this inhibition problem that we have as we age. Now, speaking of problem solving, older adults use more of their brains when they solve problems than younger adults do. As a result, that may be a result of, as we're pruning and, like I said, honing our brains so that we're getting rid of neurons that aren't really being used and things like that, in our efforts to approach a problem with a reduction of neurons available to us, we may actually invoke parts of our brain that we wouldn't have had to invoke when we were younger. We have fewer parts of our brains that are not already doing something as we age. When we're young, if you guys recall, we have all this plasticity. We have all of these association areas that are just waiting to be encoded with the information that we're going to encounter in our lifetimes. Well, as we've aged, we've been encoding things into our brains. And so we have fewer and fewer association areas, less backup brain available to solve problems. And then, of course, like I was talking about on the last slide, the loss of inhibitory mechanisms. So what that means is that we might be distracted by a variety of things. Things might catch our attention and cause us to go off track while solving the problem. We may frame it wrong because we got distracted by a particular portion of the problem, and that caused us to set up the entire problem incorrectly. All of these things mean that it may become more and more difficult for a person to multitask as they age, to literally think about one thing while doing something else, things like that. We may have more and more difficulty with that. So all of these things are probably tracked back to the fact that our brain has been getting honed to best represent the environment that we have been exposed to so far. Okay, so memory. Okay, bringing information in from the outside world is called input, as you recall. And because as we age, our sensory system, all of our sensory systems are deteriorating, there's a higher probability that we're going to miss some information and not even have it reach our working memory. So as you recall from the last chapter, our vision's deteriorating, our hearing's deteriorating, our smell, our taste. All of these things are becoming less sensitive, and as a result, less information is reaching the brain. The good news is most elderly people don't notice gaps in the information because they have so much experience with the world, and they know how important context can be for filling in gaps in what's coming in through their sense organs. So most elderly people don't even notice that they are doing a lot of what we call drawing inferences, guessing what you must have said even though they missed a couple of words, or assuming that the scene that they're looking at is completely coherent and accurate, even though they've got some blind spots thanks to deteriorating vision. So thanks to their wide experience and their use of context, most elderly people don't notice that they're having gaps in their input. Of course, this can contribute to errors. If you hold an older person accountable for every single word that's uttered, you may notice that they actually are not collecting every single piece of information coming in. They may draw incorrect conclusions about what was said or what was shown. And because of their experience, they assume that it's probably what they were expecting, when in fact it wasn't what they were expecting. And so their great skills can also cause some errors. Interference, which we've been talking about a little bit already, distractions and competing information can take what limited sensory input we have and devote it to the wrong stuff, right? So I'm trying to watch TV, but my neighbor upstairs is having an argument and I just can't tune it out, and so I'm having difficulty processing the information that I want to process. Or I'm trying to read in preparation for my my lifespan development class, and I keep hearing the music next door, and all I keep thinking about is the music and I can't tune it out. That kind of competing information is going to make it more difficult for an older person to concentrate and to encode what they want to encode. So I mentioned a second ago working memory. That's whatever you're currently thinking about, right? So anything that is in your current awareness would be working memory. Distractions are going to make our working memory less effective. And so as we age, the fact that we're more distractible means that our working memory is not going to look as efficient. That means that we're not going to be able to hold as much information in our working memory. So more things are going to get missed, right? Out of the visual field, the auditory stream, whatever form of input it's coming into our working memory, we're going to miss more of it because we're distracted, and also because we can really literally hold fewer bits of information in our working memory as we age because our hippocampus is getting smaller. And so all of these things come together to make our working memory less effective. Now, with regard to long-term memory, we know that older people have a lot of information in their long-term storage banks, because even if they can't on purpose, generate the name of their classmate from their graduating class of 1954, If we show them a school yearbook and they see the face of that classmate, they'll absolutely recognize that person. So we know that older people have really long-term memories stored, as well as things from yesterday that they might say they don't really remember. Like if I said, "What did you have for dinner?" And the older person might say, "Geez, I don't even remember. What did I have for dinner?" If I show them pictures of 3 options, one of which is the thing they actually had for dinner, they'll be able to very accurately recognize, "Oh yeah, that's what I had." So they, on average, are not having difficulty storing new memories. It may be more a problem of retrieving them. They may actually have more of a retrieval issue. Now, we do know that emotionally salient information is better remembered than neutral information. So what did you have for dinner last night is more likely to be greeted with, "I don't remember," as opposed to, "Tell me about that sad movie you saw last night." Emotional content, all of a sudden, they're going to remember all sorts of details. They're going to remember all the things that go along with it. So emotionally salient information, things that invoke their other parts of their brain that include the limbic system, is going to be more memorable. Now, one aspect of memory is, the fact that we need good cues in order to remember things, especially if we're going to use recall as our measurement technique. So if we can get an older person thinking in the right chain of thoughts, just like any other age group, they're going to do a better job of retrieving their information. Just like any other age group. We talked about this with very young children too. All of us, very young children are absolutely not concerned about the fact that they can't remember anything. They do not care. Mom or grandma, somebody will be their memory for them. As we age, we expect ourselves to be able to remember things with very little effort and with very inadequate cues. We think we should be able to, and then we hold ourselves accountable for it. If we can prime our memories with proper cues, we find that even as people age, their memories are really good. Now, the thing is, if an older person has convinced themselves that, well, I'm getting old and, my memory's really going, it may interfere with the ability of priming or good cues to actually prompt their memories. So we kind of have this battle that we have to fight as we age to remind ourselves that we aren't necessarily going to be losing our memories or whatever. That in fact, just relax, just like you used to when you were 19, thought, everything was great. You were very forgetful. Relax, you'll remember things. So older people oftentimes hold themselves to too high of a standard. I'm going to finish out this segment by just making a nod to the role of health, and then in the next segment we'll talk about some health conditions. So the role of health in cognition. Better predictors of cognitive ability than age would be morbidity, disability, and vitality, these measures of health that we've been talking about. So we have to remember that morbidity, disability, and vitality are affected by age, but that we all sort of age in different ways. And so we can't say that just because a person is X number of years old, that they by definition are going to have some kind of cognitive deficit or something. We do see one thing that differs from that general rule, and that is something called the terminal decline. For all of us, we see that as we're in the weeks or months leading up to a natural death, so I'm not talking about a person being hit by a bus. That's obviously not going to display terminal decline. We're talking about as we're aging and we're getting closer to winding down, we see cognitive abilities winding down. We see a decline in cognitive abilities as we approach death. We don't see this decline years in advance. We see it in the weeks or months leading up to it. Normal declines that have nothing to do with the terminal decline, those are the ones that can benefit from training. And so the things I've been talking about so far about, playing bridge and other kinds of things like that, those are factors that are normal declines. The terminal decline is a different kind of normal decline that you can't avoid because you're in that last bit of life where you're starting to move towards winding down. Okay, so that's a good place to stop for this section. I'll move on to diseases that can affect the brain and cognition in the next lecture.